Okay, these notes are for Angel and the boys' first period. There's 3 of you first period that need to watch this. So, hello, everyone. This is sort of chapter 3. Chapter 3 is going to be the easiest chapter of all of the geometry things. So, after chapter 2 just really mind blew us here, this is really nice to have chapter 3 kind of be an easy chapter, okay? 3.1 is all about reflections, okay? And you guys should have a note card, so make sure you have a note card for this section. Note card, that's what we're going to use, kind of. We're not going to write anything on the note card. We're just going to use that note card to measure things, okay? Now, one thing that we're going to do for reflections, okay? Write this down for reflections. A reflection is a type of congruence transformation. Yeah, we've talked about that before. Okay, what's it mean to be congruent? Do you remember?
The same.
Same what?
Size.
Same shape, same size. Okay, and here's what I mean by that. Okay, it is a congruence transformation, meaning that when we reflect things, like reflect them over top of lines, that type of thing, we're not changing the shape and size of it. So as you're drawing these, if the thing that you draw doesn't look the same shape and same size as what you had before, you did not do it right? Okay, so they want us to, first in example 1, they want us to reflect this image over top of this line. And you're not going to just willy-nilly like draw the thing, whatever, right? We're going to do this high-tech. That was pretty good. We're going to do this high-tech, and this is going to be hard for me to explain with like having to record this video. But here's what you're going to do. You're going to take your note card, and you're going to butt the bottom of your note card up against this line. And you're going to have the side of your note card go through the vertex A. So like this is where your note card lives. Okay, something like that, okay? And you're going to use that to draw this line to connect him. Now, why do I want to butt that note card up against this line? That ensures, yes, say it louder. That ensures that this is perpendicular, right? That ensures that those are perpendicular. So you're taking your note card and you are putting it on the line. Okay, putting your note card on the line so that the edge of your note card goes through that vertex, yeah? Makes sense? So that you're making that to be a 90-degree angle. We are using the note card, the edge of the note card, to make a 90-degree angle with the line, right? We want to make it perpendicular. Good? Okay, now the next step is that we're going to take this note card and we're going to use it and we're going to put it up against the line that we just drew and use it to extend our line out a little bit further, right? Okay, so you're going to extend the rest of that line down below so that we can move A onto that line, okay? All right. Good? You're confused? Okay, let's go to part B. B is this dot right here. So what I want to do is I want to take my note card and I want to butt my note card. I'm going to have the corner of my note card doing like this motion right here, right? This is the corner of my note card. So my note card looks something like that, right? So that I can ensure that that is a 90-degree angle looking like that, right? You want to ensure that that's a 90-degree angle. Okay? And you do the same thing with C. I'm going to take my note card and I'm going to butt it up against there. So my note card is shifted over here to ensure that that is a 90-degree angle.
Do we extend the lines?
Okay? And you're going to extend the line as well. Yep. You're going to take that note card and make that straight line extend down. See, I'm freehanding it, and that's why it's bad, right? You're going to extend those lines on down, and then we're eventually here in just a second. After you do that, we're going to put those points down below, okay? So just extend those lines out, but using the corner of the note card ensures that it is a perfect 90-degree angle. That makes it really nice, okay? All right, I'll give you a second until you get to that point, okay? Good? Are we doing okay so far? Okay, I'm going to erase some of my lines up here. These are all my note cards up here. I'm going to erase some of those things. I erased too much. So these are my lines. Oh, no, I'm still erasing. These are my lines here. This line and this line. Those are my perpendiculars. Okay? All right, next thing. We are going to use the note card, but here's what I want to accomplish with the note card. I want this distance to now be the same as this distance. So how can I use my note card to measure those distances so that I can put A in the bottom spot? Does that make sense? Okay, so I take my note card and I put him against here, right? And I'm going to mark on my note card how wide that is, and then move it down so that my note card is like here, and then you're going to measure that and you're going to put a dot there. You're using your note card as a measuring device, okay? And you're going to just move that dot down. So A will be like someplace down here, so that this distance here is the same as this distance. You're using your note card to measure those things, okay? And we're going to call that guy A prime, right? A with an apostrophe, and that tells me that he's the second version of A. You're going to do the same thing for B. So I want this distance to be the same as this distance down here. You're going to use your note card to measure that and mark it off, and then you're going to transfer that B down below. So this is going to be my B prime. C, you're going to mark him off, and you're going to figure out how far to go down, and then you're going to connect at the end. Connect all three dots. And if your triangle does not look the same shape and same size as the one that was above,
That's pretty. I like it.
yeah, it's a very exact way of getting it very nice, right? Better than just eyeballing it, you know, whatever. It's a little bit of work, but, you know, the rest of the stuff in this section is not terribly hard. So you got the time to, you know, be precise and do some nice measurements. Okay? Good? And all we're doing, we're not even using a ruler. We're just using a note card to like mark off stuff. So you're going to have like pencil markings all along the sides of your, so use all four sides if you need to, and then use the back side if you need to, if you have too many markings, you know, whatever. Okay, good? Happy with that? Should be the same shape, same size-ish, right? Okay? Good, good, good. Okay, let's go to the next example. And this says that we are shopping. We're going shopping, and we are going to stop in store B. Okay, do you guys see the entrance of store B? Mm-hmm. Like right here, I'm going to put a dot right there on the entrance of store B. Let me make him a different color so we can see him. The entrance of store B is that dot right there, so we're going there. And then they also want us to stop in store G. So we're going to stop in store G. And we can park anywhere along here. But if I'm going to B, then going to my car, then going to G, where do I want to park? Right? Like if I park like right here, I'll be really close to B, but I'll have a long ways to travel to get to G. So which way is the shortest distance? And here's how this works. So what we're going to do is you're going to take your note card again, and we're going to take, and just like we did before, we're going to transfer D down to here. So we're going to use our note card and make a perfect 90-degree angle here. Okay, and then you're going to extend that line on down here and measure that so that the B goes all the way down below. I don't know how far. I'm going to try to do this with my note card. Sometimes it fusses at me if I touch things. Here we go. So I'm using my note card. I'm touching it and it doesn't like it. Okay, so there's my line with my note card. There's a 90-degree angle. And okay, I'm going down. And there's where B is. Okay, there is B. This is like B prime. And then all I do is I connect that B prime that's reflected down. I connect that dot to the storefront of G, and that's going to go exactly through the stall that I want to park in. Okay? This stall right here is like where he's going through. I think he's like the 1, 2, 3, 4, 5, 6, 7th stall over. That is where I want to park in order to ensure that that's the shortest distance between the two, right? If that's the route that I go, that's the shortest distance. Okay? And then I have Jayton this morning that says, well, what if somebody's already parked in that stall? I don't know. Then you're just out of luck. You move the car, right? Run into them. I don't know. I didn't condone that. Don't tell people I'm saying run into cars. So add that to the list. Oh, jeez. Oh, jeez. Oh, great.
Great teacher.
Mm-hmm.
So much is going to be the reason why.
I know. You guys make bad life choices, and you can just blame it on me, I guess. Whatever.
I mean, you see, my math teacher.
My math teacher told me it was acceptable. So anyway, that's where you want to park. That's the shortest distance, so that's kind of nice. Okay? Now the rest of this is just really super easy. We're just graphing points and such, okay? So let's graph these points. JKL, 0, 3 is J. K is -2, -1. Here he is. And L is -6, +1. JKL, and we're going to connect those dots and make a nice, pretty triangle. He's okay. He's good. Okay. Okay. And then after we graph him, we want to reflect him across the line x equals -4. Okay, so let's draw that line x equals -4. How do you draw x equals -4?
It's
A vertical line. You go to -4 on the x, right? And then you draw a straight up and down line. So on -4, there he is, right there. Okay? All right, now here's the problem. My shape is like sitting on top of that thing, right? So how do I flip him if he's sitting on top of it, right? So I'm going to start with like L. L is on the left side over here. Whoop. L is on the left side over here, okay? And he is how many units away from that line that I'm trying to reflect? Like 2 units, right? 1, 2. So I'm just going to take that and I'm going to go 1, 2 in the opposite direction. And here is where L lives, except we call him now L prime. You put the apostrophe after him, right? How many units is J away? 4 units, I think. So we got to go 4 units over here. You're going to be 1 off the chart. So this is J prime. There's where he's going to be. And then K is 2 away, so you're going to go 2 away in the other direction, and this is K prime. And then you just connect your dots again, okay? And you want to make sure after you've done this, is he the same shape and same size as he was before? He should be. If he's not, you did something wrong. Good? Not too bad, right? Okay. All right, that was when you're reflecting across lines, like weird lines, like x equals -4. Now it gets a little easier when you're just reflecting over the x and y axis, okay? So let's go down to the next page, and I think we've already done this before. When you're reflecting across the x axis, okay? Let's do this over here. Do this real quick for me, okay? I'm gonna draw just a short little graph, and let's talk about the point 2, 3. So 2, 3 is this point that lives up here, okay? And let's talk about reflecting him across the x-axis. So that point 2, 3, if I reflect him over the x-axis, that's this guy. He's going to be flipped down here, and what will the coordinates of that point be? 2, -3. Exactly. Okay. So, yeah, exactly. It's kind of like similar to like when we were doing algebra last year, when we were trying to find the x-intercepts, you plug 0 in for y, y-intercepts, you plug 0 in for the x. It's the opposite, right? So when you're doing over the x-axis, all of your x, y points are going to become x -y. The y's become negative. And if the y's are already negative, a double negative makes a positive, right? The y's are going to become positive if they're already negative. So that's the rule for going over the x-axis. Just the opposite one becomes negative, okay? So now, if I go over here, we're talking about reflecting over the y-axis, okay? Here's my point. I'm going to pick on that point 2, 3 again. But this time I'm reflecting him over the y-axis. The y-axis is this one, so he's going this direction. And he's going to be the point -2, 3. So in that case, the x-coordinate becomes negative, okay? Or it becomes positive if it's already negative. So the rule is that x, y becomes -x, y. Yep, just the x's become negative. That's the rule. Happy with this? This is not too hard. Okay. All right. So before we graph these guys, we're going to start with A, B, C. I'm just going to write these points out, and rather than graphing them and trying to figure it out, let's use that shortcut. Okay. So there's my original guys, and I want to find A prime where he's located, B prime where he's located, and C prime where he's located. Okay. And we are going over the x-axis. Okay, which means that the y's have to become negative, right? Okay, so A prime is going to be where? -5, -3, exactly. What about 2, 0? It's 2, -0. It's, yeah, so 2, -0, whatever, 2, 0, okay? And then this guy's 1, -2. Okay, let's plot those and see if we have successfully done that. We have -5, 3. I'm not going to label my points, so I'm not too crazy weird. This is really not a nice triangle. It kind of looks like a shard of glass or something. I don't know. One of them weird things. It's like a really weird one. Yeah.
This is really weird.
This is really yucky. It's not like a fancy little triangle.
I don't think I did this right.
2, 0.
Maybe I
that guy, and this guy. He looks like this. Yeah, he's weird to start with. That's what he looks like. Okay. Now, how come that 1 point doesn't move? Like 2, 0, we said 2, 0 doesn't move. It's on the x-axis. So if I'm reflecting it across this line and he lives on that line, he's not going to move, right? Okay.
That's weird.
That is weird.
Looks like a weird pair of like wings. What's
coordinate
notation?
Coordinate notation. This guy right here.
Ew.
So down here, what?
Is that what we did up here?
What? No, this one we just graph the thing. So graph and its reflection, blah, blah, blah. They just want us to graph it, okay? Part B says describe the transformation using coordinate notation. So we're starting with PQR. That's this left, the one that's mostly on the left side, right? Okay? And just to figure this out, I'm just going to specifically look at P, okay? What are the coordinates of just P? Negative 4, 1. Okay, now what's the coordinates of P prime? That's this guy over here.
4.
Positive 4, 1. Okay, so my x, y, to use, they say use coordinate notation. So my x and y are now becoming, what's happening? Negative xy, right? The y's stay the same, but the x becomes negative, and by making him negative, he becomes positive if he was already negative, okay? So this is using coordinate notation. What type of transformation is that? Yes, that's what we're doing right now. So this is coordinate notation. What type of transformation is that then? It's the reflect over y. Okay, so coordinate notation, that's what type of thing it is, okay? Good? All right, now there's one more type of transformation, or one more type of reflection, and it is across the line y equals x, okay? All right, so let's go down here, and I'm going to just kind of like how I explained with you the 2, 3 thing before. Let's plot that point 2, 3, right? 2, 3 is that guy, okay? And we want to reflect over the line y equals x, okay? Let's talk about y equals x. That's a linear function, right? Right. How would you graph y equals x? It's a diagonal. But this is like y equals x plus 0, right? So we would start at 0 and we would go up 1 over 1, up 1 over 1, up 1 over 1. And that's why he's a diagonal line. This is the line y equals x. Or down 1, left 1. Y equals x is that diagonal line because you're starting at 0, going up 1 over 1, down 1, left 1. Okay? I want to reflect that point 2, 3 across this line. Okay? Do you see where he's kind of going to live? He's going to live like over here. Do you see that? Okay, what's the coordinates of that point going to be? Yeah, he's like going over 3 and up 2, yeah. So what's the rule? What's the rule for y equals x? xy is going to become yx. You just switch places with each other, right? So when you're reflecting across that dotted line that's diagonally, the y equals x line, you're just flipping your x's and y's. Okay, so that's what we're doing here.
Why are you so surprised that I knew that?
I just was like, how'd you get that? Like, I was so
If
lost.
you look at it.
Yeah.
Clearly
She's
you think I
thinking
am
too
too.
hard. I don't know. She's thinking too hard. Okay, so I'm going to list out these points. JK, I don't know why I have JKJM.
Where's Luke?
Is there 2 J? Oh, no, that's an L. That's an L. JKLM. And M is 0, negative 4. Okay, so those are my original ones. And I want to write out what J prime, K prime, L prime, M prime are. Okay, and these are just switching the places of each one. Okay, so now the weird part is 2, 2 just stays 2, 2. Why does that stay?
Because it's on.
2, 2 is going to be on that y equals x line, yeah. This guy's going to become 1, 4, negative 3, 3, and negative 4, 0, exactly. Okay, and let's plot those guys, and then we'll be done. 2, 2, 4, 1, 3, negative 3. I'm not going to write out the names of them, just so I don't bog down my graph here. Do you know what shape this guy is? What is that thing?
It's not a trapezoid.
It is a trapezoid. Yeah, that is a trapezoid. Yep. We learn lots about trapezoids here later on in the, like in chapter 4, I think. We talk about trapezoids and squares and rectangles and parallelograms and. Yeah. I like teaching that chapter, actually. It's kind of fun. Okay, 2, 2, 1, 4, negative 3, 3, and negative 4, 0. There we go.
I don't like it.
Okay, is he the same shape, same size?
Yeah.
You betcha he should be. If he's not, you did something wrong. There he is. He's flipped over. There he is. Okay. Good, good. Happy with that? That's all.
No homework.
On your homework assignment, we will do all on both sides, except there's only 8 problems on this side and 6 problems on this side. So we'll do all in all, except I said since there's 4 of them here, you can skip 2 and 4. Okay? So it's really only, like 12 problems for homework, and they don't take very long, okay? So all, but you can skip 2 and 4, all, and that's it. Okay, good? Skills practice, skip 2 and 4. Skills practice has 4 of them that you have to draw. Practice only has 2 of them you have to draw, right? So this one you'll skip 2 and 4, okay? There you go. Everybody say bye.
Randomly bleed out of my fingers.
I don't know where I'm at here. Escape.
Is that why?